Welcome back to day 11 of our 100 Days of Architecture and Verilog series. Today we are diving into the fundamental tool for any hardware designer, system task. Think of this as the cheat codes of Verilog Simulator. This will help you to talk to your design, see what's happening inside and control the simulation flow. Let's get into it. So what exactly are system tasks? They are built-in functions provided by the simulator to perform operations like printing the data to your console or monitoring signal changes. The easiest way to spot them is the dollar sign. In Verilog, if it starts with a dollar, it is a system task. Some of the most common ones you will use are display, dollar monitor, dollar finish, and dollar write. Let's break down the important ones. So in this we have dollar display and dollar write. First up, getting information out of your simulation, we use dollar display and dollar write for this. Dollar display is your go-to. It prints a message automatically and adds a new line at the end. So your next message starts on a fresh line. Dollar write is also identical, but it does not add the new line. Use this when you want to build a single line of output across multiple commands. To make this useful, we use format specifiers. Use dollar percentage %d for decimal, percentage %h for hexadecimal, percentage %b for binary. If you want to see the current simulation time, use percentage %t along with dollar time task. This is the example for your display and where we use this format specifier. We'll see the particular example on a EDA playground tool. Now what if you want to track a signal every time it changes? You could put a dollar display on every line, but that's a headache. Instead, you use a dollar monitor. Unlike dollar display, which only runs when the simulator hits the specific line, dollar monitor runs in the background. It stays awake and automatically prints a message whenever any of the variable you listed change their value. Pro tip that I would like to give you is only $1 monitor can be active at a time. If you call it again later in your code, the new one will completely replace the old one. It means if you are using 2 times dollar monitor, the first one will get replaced by the newer one. That is what I mean to say. Here see, I use the format specifier percentage %0t, a equals percentage b, b equals percentage b. So it will print in binary. The time will be printed in time and a and b will printed in binary. Next we have dollar finish and dollar stop. Finally, how do we end the show? When you write a module like the design code or the test bench code, you need to finish it, right? So at that time we use dollar finish and dollar stop. Dollar finish can be taken as the exit button. It terminates the simulation entirely and closes the simulator. But dollar stop is very similar to dollar finish, but it is just like a pause button. It suspends the simulation and enters the interactive mode. Dollar stop is a lifesaver for debugging because it lets you halt the timeline and inspect your waveforms at specific point without having to restart the whole tool. Let us see it in action on an EDA playground. Notice how dollar monitor catches every change in the count variable, while our dollar display only fires when we reach a specific condition. You can see the simulation starting for day 11, tracking the data using dollar monitor, and finally end with dollar finish. Where have we used dollar finish? Yeah, we are used it here. After simulation ending, it means that the code has terminated successfully. Here you can observe for this particular monitor dollar monitor system task, every time the count gets incremented, my time was also increasing because I have given a hashtag 5. For every 5 clock cycle it will increase. Let us see, for time 0 the count is changed to 0. It means the count has been incremented. Again it changes to 0. I am also telling that at time 45, when we reach the middle of the count, time percentage t we reach the middle of the count. It is because after the particular clock pulses, when my count is equal to 4, I have already said that if count is equal to 4, display that we reach the middle of the count. That is why this is displaying here. And at $time 45, monitor count changed to 5. The simulation is ending. This is how we are going to use system task in our test benches. Comparison. This is very important. $display is used for printing the message only once, and it executes only when it is called. But $monitor is not like that. Monitor keeps on observing the signal changes and prints it. Here you can see we have used it only one time, but $monitor will keep on repeating whenever the value changes. It executes automatically whenever signal changes. $finish is like exiting the simulation, stops the tool completely. $stop is a pause simulation. It halts the time for manual inspection. That's a wrap on day 11. If you have any doubts, feel free to put it down in the comment section, and I'll get back to you. Don't forget to like and subscribe to EC TechNest and keep building. I'll see you for day 12. On day 12, we'll be covering a small mini project on ALU design. Thank you.